Hi, this is Kevin at the Virtual Planetarium at Raritan Valley Community College. Welcome to our weekly Star Talk. Today we're going to be talking about the International Space Station. But before we do that, let's talk about our upcoming moon phases. We have a new moon on October 6th, we have a first quarter moon on October 12th, and then the full moon of the month is going to be on October 20th. Not quite lined up with Halloween, but it can't be perfect every year. Oh well. And like I said, today we're going to be talking about the International Space Station. Now, what is the International Space Station? Basically, it's just a laboratory in space. It's a joint effort by many countries so that scientists can have a unique environment where they can test out many different things, including how humans can survive in space. Now, what makes the ISS, which is short for International Space Station, special is that it is in a microgravity environment. And that means that the astronauts and everything inside the station actually floats. Now, why does it float? Why does it not have any gravity? The reason the astronauts don't feel gravity is because the space station is actually orbiting around the Earth. A lot of people think that astronauts don't feel gravity because they're far away from the Earth. But in reality, first of all, the International Space Station isn't that far away from the Earth. It's only about 250 miles above the surface. And second, you can feel the Earth's gravity pretty far away from the Earth. Even the moon feels the Earth gravity. So it's definitely not because of distance. The weightlessness is, again, because the ISS is orbiting around the Earth, it's in something called freefall, which makes everything inside of it feel weightless. It's actually a pretty hard concept to explain, so I'm going to put the link in the description of this video for this little game right here, which you can actually explore why do astronauts float in space. It's actually a lot of fun, and it's free, so you can check it out and play around with it, and learn, again, why astronauts float in space. Okay, now you might be wondering why we're talking about the ISS this week. After all, isn't this channel about things that we can see in the sky? Well, you can actually see the ISS very easily in the sky. The space station orbits the Earth around 16 times a day, which means that it is constantly in a different part of our sky. But when you do see it in the sky, it looks like a very, very bright moving dot, which you can sometimes see in the sky for about 7 minutes at a time. Okay, that's cool, but how do we know where to look for it? Well, since it's going around the Earth so often, you actually need a little help to find the ISS in the sky. And for that, we can use this website right here, which is called Spot the Station. I'm going to put the link for this in the description as well, so you can check it out. And here we can actually put our location and learn about what the next sightings are going to be. Right now I have it set up for Central New Jersey, and we have a list of the next sightings for the next 2 weeks. And let's go over this table and see how we can read this. For an example, we're going to take the pass of Monday, October 4th, and we can see in this first column right here, we have the date, and we have, again, Monday, October 4th, and we see at what time the ISS pass is starting. We see that it's at 7:50 at night. In the next column, we can see how long it's going to take. This pass is going to last for about 5 minutes, but the one next to it is actually going to be about 7 minutes, so that's a really long time. We can also see how high it's going to be in the sky. This one right here is going to be 88 degrees up in the sky, and that means that it's going to be basically directly over our heads, which is really cool. And then it tells us where it's going to appear from. That means where it's going to start being visible, in this case about 10 degrees northwest. And then where it's going to disappear, and in this case it's going to be about 31 degrees above southeast. So this table gives us all the information we need about where the ISS is going to be so we can actually see it in the sky. Now let's use our planetarium sky so we can actually see this example in real time. I have the sky set up for October 4th, and we have it for about 7:50 at night. Actually, we have it for exactly 7:50 at night. And we are looking towards the northwest, which is where the website said the International Space Station is going to start rising from. And in fact, we have a very bright dot right here that we can see. As time goes by, we see that the ISS is rising in the sky, and like the website said, it's going to be passing at above 88 degrees, so that means directly overhead. And now we have about 7:54, and we said that the pass was going to end at about 7:55. So when we get to that, we're going to notice that the ISS is actually going to disappear in the sky. So we can fast forward for a second so we can see it. and then at 7:55 roundabout, it magically disappears in the sky. So that time window is actually very, very important. Now, this pass is going to happen on October 4th, and it's going to be really high up in the sky. Again, it's going to be about 88 degrees overhead, which means it's going to be a great view. But personally, I'm really excited for the one that's going to happen on October 6th, and that one's going to start at about 7:52 at night, and it's going to be up in the sky for about 5 minutes as well. And you notice that the max height isn't going to be that high up. It's going to be very close to the horizon, actually. And you might be wondering, why am I excited for this one? It's less special than the other one. And I'm really excited for this one because it's actually going to be going very close to Jupiter and Saturn in the sky. So towards the end of its path, we're going to be able to see this beautiful triangle in the sky of Jupiter up here, Saturn over here, and then the ISS right below it. So Wednesday, if you look towards the south between 7:52 and 7:57, you're going to be able to see the International Space Station zoom on by in the sky until it's right by Jupiter and Saturn. So that'll be pretty cool. Now, as we saw, it's really just going to look like a very bright moving dot in the sky, but very important is that it's not going to be blinking. If you see it blinking in the sky, then it's not the International Space Station, it's just an airplane that's happening to go in the same part of the sky at the same time. But now, you might be wondering why we can see the ISS at all, why it's so bright in the sky. Well, the International Space Station is so bright because it reflects sunlight. It doesn't have any lights on the outside that are shining towards the Earth, but it is very reflective. It has these really big solar panels, and while these solar panels only reflect about 35% of the light, they're really, really big, so it still looks pretty bright in the sky. And then the rest of the body of the International Space Station actually reflects about 90% of the light. And this is on purpose because the more sunlight it reflects, the easier it is to control the temperature on the inside for the astronauts. Now, because we can see the ISS from this reflected sunlight, that's the same reason we don't always see it in the sky. And that's also the reason we don't see it set over the horizon, and sometimes it just disappears in the sky altogether. Here we have a little diagram. We see the International Space Station right here, and then the Earth, which has daytime and nighttime side. And then we also have the shadow of the Earth right here. So during the day, we see the sun is hitting the ISS and it's reflecting back to the daytime side, but the sky is so bright during the day that we just can't see the ISS even though it's being hit by sunlight. But as the day goes on, as the minutes go on, the ISS keeps orbiting around the Earth, and then even though we are at nighttime over here, the ISS is still getting hit by sunlight, and that's why we can see it reflecting the sunlight in the sky. And that's why we can see it move along our sky as it's moving along in its orbit. Now, eventually it's going to keep following its orbit and going to the shadow of the Earth right here, and that's why it disappears suddenly in the sky instead of setting over the horizon. So when the ISS is in the Earth's shadow, the sunlight can't hit it, and so it can't reflect any more light down to us. So that's why we see it disappear all of a sudden. Now, because we can only see the ISS as it's outside of the Earth's shadow, that means that we can only see it shortly after sunset or shortly before sunrise, because that's when we're close to that line between daytime and nighttime, and so that's when we can see the ISS reflect the sunlight. Now, the ISS is actually not the only satellite we can see. There are many, many satellites that paint the night sky, that cover the whole night sky. It's actually pretty beautiful to see, but it can also be a problem for astronomers that are trying to take pictures of the sky to study it. Now, the reason the ISS is so much brighter and easier to see is that it's actually closer and it's a lot bigger than all the other satellites. So that's why it's a lot more famous and easier to see in the sky. Thank you so much for joining us today. Hope you learned something new. You should definitely go outside and try to find the International Space Station. If you can't this week or it's cloudy, again, it goes around the Earth about 16 times a day, so we have many, many opportunities. You can check out the Spot the Station website and use that to find out when the next good seeing is going to be for the ISS. Once again, thank you for joining us and hope you have a great week.